Imagine a factory in 1970. Everything looks clean, modern, and high-tech. Technology has just entered a new era: miniaturization, transistors, and the first integrated circuits. But problems start appearing soon. Chips fail. Not immediately. Not everywhere. Not in the same way. One board works, another behaves strangely, a third fails after a week. Failures occur even in critical areas where nothing can go wrong. Military systems, aviation, space technology. One small failure can mean millions in losses. The Adios 2 satellite lost power, and the mission was lost, costing hundreds of millions of dollars. The Galaxy 15 communications satellite lost control of its orientation, requiring complex procedures to regain control. On Earth, hundreds of thousands of microprocessors failed in factories, with costs in the millions. Suddenly, engineers realize the problem isn't just the technology. Some invisible force is affecting electronics on all fronts. This force is called ESD, Electrostatic Discharge. Companies like IBM, Motorola, and Texas Instruments start experimenting. They deliberately expose chips to different discharges and discover something shocking. Some circuits die at just 100 volts, even though a person doesn't feel a similar discharge until 3000 volts. It soon becomes clear where the problem comes from. The source of failures is the human operator. They approach the workstation, wearing a synthetic coat, sitting on a plastic chair in dry air. Thousands of volts of static electricity build up on their body. They feel nothing, see nothing. They touch a chip pin, and that's it. The chip doesn't explode. It doesn't blacken. It doesn't go dark, but it will never be the same again. It works, but unreliably. A shocking discovery follows. Some chips survive, at least at first glance. But inside, they are damaged, and the problem within remains hidden for days, weeks, or months. This type of failure gets a name: latent defect. To understand how such a defect can occur, it's worth briefly recalling how a charge builds up on the human body. Movement or friction against objects, like walking on a carpet, sitting on a plastic chair, or taking off a sweater, can charge your body with static electricity. When you touch metal or a chip, the charge discharges quickly. The discharge is small and invisible, but it can damage the chip. Inside the chip, microscopic damage occurs: narrowing of metallization, micro cracks, or local melting of structures. This damage may not be visible at first, and the component may initially function correctly. But the weakened area bears more stress from current and heat, gradually degrading until full failure occurs, manifesting as a typical latent defect. Today, ESD is no longer ignored. It has a name. It has rules. Workers wear wrist straps. Workstations are grounded. Floors are conductive. Humidity is monitored. Everyone knows not to touch a chip casually. ESD is part of training, part of audits, part of manufacturing procedures. Today's chips are much smaller, more powerful, and more sensitive than ever. Voltages that can damage them are often lower than we can even measure. This changed the approach to protection. It's no longer just about equipment on the bench. It's about how people move, how they touch, how they think. The war against ESD isn't over. It's just changed. It happens at home too. At your desk. On a carpet in the living room. Treat electronics as if they remember every touch. Because sometimes, they really do. In professional manufacturing, work clothing contains fine conductive threads. Shoes carry charge down to a conductive floor. When electronics aren't on the bench, they belong in special metallized bags that act like a Faraday cage. It's not rocket science. Each part does its job, keeping chips safe together. We don't fight static electricity with brute force. We simply never give it a chance to build up. Without energy, it has nothing to harm. And remember, this applies to you at home as well. If you don't have an ESD grounding strap handy, do not start assembling a PC or handling circuit boards while standing on a carpet. Before you touch any sensitive hardware, you must discharge yourself. Touch a grounded object, like a heating radiator or the metal casing of a large appliance that is plugged into the wall, such as a fridge or a washing machine. These metal surfaces are usually grounded and will safely pull the static charge away from your body.